1988, American rower John Duke designed an indoor rower which uses a special ingredient: water. He called it the WaterRower. The small town of Warren, Rhode Island, once famous for its shipyards, is now home to the WaterRower factory. Most rowing machines are constructed from metal and plastic. The WaterRower is made from a hardwood, which is both strong and durable. Operations Manager Gabriel Lewis oversees the delivery of almost 20 tons of hardwood each week.
The reason that we have a huge amount of wood is for the demand that we have. We have to build anywhere from 250 machines to 400 a day.
Each piece of wood is cut to size. Every cut has to be millimeter accurate.
What we're doing here is we're cutting all parts for that particular machine. So we're cutting the rails and all the other parts all at once.
A computer-controlled cutting machine shapes the big pieces for the rower's rails. Strong though it is, the color of the natural hardwood can vary slightly, so the wood is stained.
Our customers are very picky on color, so we have to make sure that the process is done correctly, so the parts can be all uniform in one color.
The natural material is also potentially vulnerable to rot. So after staining, the wood is sealed with a protective coat of Danish oil. At the heart of the machine is the mechanism that replicates an oar being pulled through open water. The WaterRower's trick is to bring the river indoors and put it in a custom-designed tank. Don Ruist is the in-house production engineer and charged with assembling this most important component of the WaterRower.
It starts off with a tank. It's a two-piece tank. He'll add some glue, obviously, to keep it from leaking.
The other essential for rowing, the paddle, is inserted inside the tank before it's sealed. The special double paddle design pushes the water round the tank, creating a circular flow which mimics the flow of water running past a boat. It's a simple yet effective idea, because the rower will feel the same forces spinning the paddle in the tank as they would pulling an oar through water.
The finished product is right here, and it begins the assembly process.
Next, powering the paddles. The oar stroke is replicated by a pull handle attached to a fabric belt. The difficult bit is turning this pulling force into a spinning motion to drive the paddles. This is done by attaching the belt to a cord that is wrapped around a shaft. The shaft is attached to the paddles so that as the rower pulls the cord, they drive the paddles through the water. As the rower returns to begin a new stroke, a clutch system, similar to the one on a bicycle, disengages the cord wheel from the paddles.
Here he will put the clutch assembly, all the pulleys on it, and the top deck, which makes the actual mechanical portion of the tank.
The final touch in the assembly process is a digital display that measures the effort and speed of the rower and provides feedback on the distance traveled and calories burned.
We will also test to make sure that the monitor is working correctly, so when the customer gets it, there's no issues.
Once the rower is assembled, the tank is half filled with water. Any water will do, tap, bottled, or mineral if you're posh. The added advantage of using water is that unlike some traditional rowing machines, there's no need to set different levels of resistance. Just like out on the river, the faster you row, the harder it gets. This is known as the rule of cubes. To double your speed, you have to expend not twice as much, but 8 times more energy. An experienced rower can burn off more than 100 calories in 10 minutes.